Good afternoon, students. I hope I'm audible. You can just type in the comments if I'm audible. We'll just wait for a few more minutes and then we'll begin the session. Okay, so I hope by now all of you have finished your major subjects and now you are with the computer science paper. Now, when we talk about the computer science paper, already you have done your practical, isn't it? Practical is done, and now you have the 70 marks of theory paper, which is going to be held on 27th, right? So you have already studied the computer science paper for the last 2 years for the ISC 2026. You have already studied for the 2 years, and as you all have been knowing that today's session, which I'm going to do, that is to revise your Boolean algebra part, because Boolean algebra forms an integral part of your curriculum. You have the paper, as you already know, part 1 and part 2. That part 1, that is 20 marks, again it contains few questions of Boolean algebra, and again part 2, section A, that is entirely of Boolean algebra. So it is an important part, and that's why I thought to cover this Boolean algebra part, because this portion will be giving you 20 to 30 marks will be there from this section. So it is an important part. Now, when you talk about this Boolean algebra, I'll be just discussing, and then I'll be using the whiteboard as well to make you understand. Now, when you talk about this thing or this section, we have the important things, that is proposition logic. Then we have the well-formed formula, truth table, interpretation of well-formed formula. Then the different proposition logics are there, and then we have this Boolean algebra is there, the logic circuit, the digital circuit is there. Now, when we talk about the first thing which comes here is proposition logic. What do you understand by proposition logic? When we say proposition logic or a proposition is basically a statement which results in true or false, right? A proposition is a statement which results to true or false. Like if I say a statement, the weather outside is too hot today. It's a sunny morning, it's a sunny day. Now it's a sunny day, it can be either true or false. For example, here if I'm talking about, here it's sunny. So the statement, it's a sunny day today, that will return true. But if I talk about a place where it is raining now, if I say it's a sunny day, that will be false. So a proposition is a statement which results to true or false. That part, I hope it's clear. As I'm telling you, could just take a note of all the things which are, and if needed, you can just use it and for revision purpose. So that's a proposition, a statement which results to true or false. Now, when we talk about propositions, there are two types of propositions: simple proposition and compound proposition. A simple proposition is a single statement, right? A simple proposition is a single statement. A simple proposition is a statement which is having a single statement. That's a simple proposition, a single statement. That's simple proposition. If we talk about compound proposition, a proposition which is formed of two statements, that is a compound proposition. So a simple proposition contains a single statement, compound proposition contains two or more statements. Now when we talk about a compound proposition, this compound proposition, it can be formed or it is formed by combining two statements. Now to combine the statements, we need certain connectors, right? We need certain connectors to combine the two statements. Now when we talk about the different connectors, right? When we talk about the different connectors, so we have the first one is disjunction. Disjunction. That's the first this connector, disjunction. Then we have conjunction. Now let's talk about disjunction and conjunction. When we say disjunction, a disjunction is a statement which or a connector which results true when either of the statements are true. If any of the statements are true, then disjunction results to a true value. So it is noted by the symbol V or it is noted by plus. Right? It is noted by this V or it is noted by plus. Now, if we talk about the truth table of a disjunction, if I say this one, okay, A, B, and Y, 0, 0, 0, 1, 1, 0, 1, 1. If either of the statements is true, it will return a true value. So it is 0, 1, 1, 1. This is disjunction. So disjunction is used as or either of the statements, either of the conditions is true, it will result a true value. So that is disjunction. Now when we talk about conjunction, conjunction is a statement which returns true when all the statements are true. So it is like this. Or it is noted by. Now when we talk about a conjunction, its truth table will be zero, 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 1, 1, 0, 1, 1. When all the statements are true, it results a true value. So that's a conjunction. When all the statements are true, then it will return a true value. After conjunction, we talk about negation, right? A negation is just like a complement. So this is negation. It's not like this. Okay. Now, if I say A and this is Y, A is 0, it will be 1, it is 1, it is 0. That is negation, right? So negation is used to obtain the complement. Then we have double negation. Double negation, just double complement, right? Double negation, it is double complement. It can be noted as this. So, this is Y part, 0 and 1. So it results the same value. So we have this conjunction, disjunction, negation, and double negation. Negation gives the complement and double negation results the same value. It's double complement. Then we have implication. Implication. It is also known as conditional, right? It is also known as conditional. Now, conditional, what happens? A implies to B. If it is A, it is like it can be noted as this, or it can also be noted like this. A implies to B. Now, in this, what happens? For example, it is A, this is B, and this is Y. 0, 0, 0, 1, 1, 0, 1, 1. In 0, 0, it will return 1, 0, 1, it will return 1, 1, 0, it will return 0, and 1, 1, it will return 1. So that is implication. A implies to B. It is also like A implies to B. If this, like if I say a statement A, you study well, and then again, you will get good marks, right? You study well, you will get good marks. Now, if I combine it like this, if you study well, you will get good marks. Right? If you study well, then you will get good marks. So I'm combining it with if and then. So if you study well, then you will get good marks. So that is about this conditional. Okay, if then. If you study well, then you get good marks. So that is a conditional statement I'm using if then. Now here what happens? A and B. A is known as antecedent and B is known as consequent. A is antecedent and B is consequent, right? A is antecedent and B is consequent. If then, okay? So now when we talk about this antecedent and consequent, A antecedent, the condition, and then the statement is the consequent. Antecedent and consequent is there. Now then we have biconditional or equivalence, right? Then next we have equivalence or biconditional. A double implies to B, right? It can also be noted as like this. A double implies B. Now in this what happens if both are 0 and 1? Like if I say A and B, A, B, Y. 0, 0, 0, 1, 1, 0, 1, 1. 1 and 1, this is 0, this is 0. If both are 0 and both are 1, then it returns true. In the other cases, it returns 0. So this is about double implication. So I hope this all are clear. Disjunction, conjunction, negation, double negation, implication, and equivalence. Now when we talk about this proposition, so these are the different propositions, the connectors. Now there is a term WFF, well-formed formula, right? Well-formed formula. Now what is this WFF? Well-formed formula is actually a system of representing a propositional statement in a short form, right? Representing a propositional statement in a short form, that is WFF. So like we use the terms, no? If I say you, it is, for example, you study well, right? You will get good marks. Now, if I say the first statement is you study well, I use A to represent it. You will get good marks, that is B. Now I say you study well and you will get good marks. You study well and you will get good marks. So A, I am using, and conjunction I can use. And if I say, but if you study well, then you will get good marks. So there I'll use implication. So depending upon what is the statement, we can use the WFF. With it, there are three more things: converse, inverse, and contrapositive. See, I'm basically focusing on topics from which you will be getting questions. So first thing we discussed about these terms, it could be there to form the truth table, we can use it. Then I'm talking about that you can be given a statement and you will be asked to find the converse, inverse, or the contrapositive of the given statement. What is converse, what is inverse, and what is contrapositive? Now when I say a statement A implies to B, right? If I say a statement A implies to B, I hope I'm audible well. Na? If anything, then you can just type in the comment box. So if I have a statement, if you study well, then you will get good marks, right? If you study well. So statement A was you study well. Statement B is you will get good marks. Now, A implies to B. A implies to B. So, what it becomes? If you study well, then you will get good marks. This is A implies to B. Now, if I have to find the converse of the statement, so converse, right? Converse, what happens? Converse is B implies to A, right? The converse is B implies to A, means if, right? If I say the statement is if you study well, then you will get good marks. Now I have to write the converse of the statement. So as I told, converse is B implies to A, right? If you will get good marks, then you study well, right? If you have to get good marks, then you study well. Next, inverse, right? Inverse. For inverse, what we do? For the inverse, we have negation of A implies to negation of B. Means if I say negation of A implies to negation of B, right? Negation of A implies to negation of B. Means what I can say, if you do not study well, if you do not study well, then if you do not study well, then you will not get good marks. Right? If you do not study well, then you will not get good marks. So that is negation of A implies to negation of B. That is the inverse. Third thing comes Contrapositive. Right? Contrapositive, converse, inverse, and then I told contrapositive. Contrapositive is negation of B implies to negation of A. Complement of B implies to complement of A. So what it is, if you will not get good marks, right? Negation of B. If you will not get good marks, then you have not studied well, right? So I hope you understand. Converse, if a statement is A implies to B, its converse is B implies to A. Inverse is negation of A implies to negation of B. And contrapositive is negation of B implies to negation of A, right? Negation of B implies to negation of A. Okay? Okay. So with this, now we talk about another thing, another important thing, that is our truth table, whether it is a tautology, contradiction, or a contingency. You can be given a statement or you can be given a expression, and you have to find whether that expression, it is a tautology, it's a contradiction, or a contingency. For that, you remember that if the truth table results all values 1, right? If the truth table results all values 1, then it is a tautology. Okay? If the truth table results all values 1, then it is a tautology. If the truth table results all values 0, then it is a contradiction. Right? If the truth table results all values 0, then it is a contradiction. And if the truth table results a combination of 0 and 1, then it is a contingency. Is it clear, students? If the truth table results 1, then it is a tautology. If the truth table results all zeros, then it is a contradiction. And if the truth table results a combination of 0 and 1, then it is known as a contingency. So I hope this is now clear again. Okay. Now, when we talk about expression, for example, if I say I have been given a statement and I have to write a truth table, or I have to verify it using truth table. For example, if I say I have to verify, if you are given, for example, I take a condition show that the expression, if I am given, show that the expression P implies to Q, right? P implies to Q is equal to negation of P implies to negation of Q implies to negation of P, right? Negation of Q implies to negation of P. I have to verify this. What can we do? I take P, I take Q. Okay. Thus I take P implies to Q. Then I'm taking a negation of P. Then I'm taking negation of Q. Then I'm taking negation of P implies to negation of Q. Now 0, 0, 0, 1, 1, 0, 1, 1. Okay. P implies to Q, as I have told, 0, 0 is 1, 0, 1 is 1, 1, 0 is 0, 1, 1 is 1. Negation of P, 1, 1, 0, 0. Negation of Q, 1, 0, 1, 0. Fine. Now, 1, 1, it will be 1, 1, 0, it is 0, 0, 1, it is 1, 0, 0, it is 0. Okay. No, sorry. 1, 0, it is 0, 0, 1, it is 1, 0, 0, it is 1. Implication. Now, if I say P implies to Q. Okay. P implies to Q, 0, 1 was 1, 1, 0 was 0. Here again, 1, 0 is 0 and 0, 1 is. So, this statement is not verified. Right? This statement is not verified. So, this way we will be solving it, and accordingly you will be okay. Sorry. Now, this statement, I changed the question actually here. Okay. So, this one I'll be just. Yeah. negation of Q, this is negation of P, right? I could have done it like that also. Negation of Q, you see, 1, 0, 1, 0. Negation of P, 1, 1, 0, 0. Right? Now here it says negation of Q implies to negation of P. Now 1, 1 is 1, 0, 1 is 1, 1, 0 is 0, 0, 0 is 0. Now if I, sorry, 0, 0 is 1. Now in this case what happens? This is the LHS and this is the RHS. Now LHS is equal to RHS, hence, right? So this could be that you have been given a statement and you have to verify whether that statement is true or false. So that could be done. So from this part till here it is that we will be getting a question and we can be accordingly solving it. Okay. Now if I say you can be getting a truth table, finding the values and again getting those results, that could be done. Contingency, contradiction, tautology. Okay. Now let's talk about the logic circuits. Okay. Okay, no, before that, let's talk about the Boolean laws. Now, when we talk about Boolean laws, that there are various Boolean laws which you need to know and you need to remember. Like if I talk about the properties of 0, we have a plus 1 is equal to 1, right? A plus 1 equal to 1, and second is a dot 0 equal to 0, right? Properties of 0 and 1. If I say a plus 1 is 1 and a dot 0 is 0. Again, a plus 0 equal to a and a dot 1 is equal to a. These are variables. Like if I say 0 plus 0, that's 0. If it would have been 1 or 0, it will be 1. So it depends on the value. Complementary law. Complementary law, if I say a plus a bar equal to 1, right? A plus a bar equal to 1. And second complementary law, we have a dot a bar equal to 0, right? A plus a bar equal to 1 or a dot 1 is equal to a dot a bar equal to 0. These are the two complementary laws. Once again, a plus a bar equal to 1, right? And again, a dot a bar equal to 0. Idempotent law. Idempotent law says a plus a equal to a plus a equal to a, and the second is a dot a equal to a. Involution law. Double complement law, we say a double bar is equal to a was 0, 0's complement 1, 1's complement 0, so a double bar equal to a. Commutative law, you have already studied in maths also. A plus b is equal to b plus a. Similarly, a dot b is equal to b dot a. This is the commutative law. Then we talk about the distributive law. Distributive law, a dot b plus c. A dot b plus c is equal to a dot b plus a dot c. Second law, a plus bc is equal to a plus b dot a plus c. That's the distributive law. Now, any of the laws if we get and you have been asked to verify, like if I say, if I take the first distributive law, a b plus c is equal to a plus b, a dot b plus a dot c, right? Like if I say, I have been told to verify this law using truth table, right? I just take the statement. The question told verify the law a b plus c is equal to a plus b dot a plus c. Okay. Now I have a, b, c, then b plus c, then a dot b plus c, then a plus b, then a plus c, then I have a plus b dot a plus c. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Now P plus C. 0 1 1 1 0 1 1 1. Okay. B plus C. See 0 0 0 0 1 1 1 0 1 1 1 1 0 0 0 0 1 1 1 0 1 1 1 1. A dot B plus C. This and this and 0 0 0 0 1 0 0 1 0 0 1 0 1 0 0 1 1 is 1 1 1 is 1 1 1 is 1. Now A plus B, OR operation here. A plus B, 0 0 1 1 1 1 1 1. Okay, I have just. So you need to be careful when you are writing. Use one line and try to be systematic. When you are making the truth table, try to be systematic and don't make it microscopic. Okay, don't write so small. So see here, A plus B, 0 0 is 0, 0 0 is 0, 0 1 is 1, 0 1 is 1, 1 0 is 1, 1 0 is 1, 1 1 is this one. Now A plus C, 0 0, 0 0 1 1. Again 0 0 is 0, 0 1 is 1, 1 0 is 1, 1 1 1, 1 0 1, 1 1 1. Okay, this is good. Now this and this 0 0 is 0, 0 1 is 0, 0 0 is 0, 0 1 is 0, 0 1 is 0, 1 1. Again 1. This will be A dot B plus C. A plus B dot A plus C. This is 1, this is 1. A B plus C, B plus C, this was this value 0, 1, 1, 1, 0, 0, C 1, 1. Okay. Now A dot B plus C, this 0, A dot 0, this one is 0, this one is 0. Yes, this one is 0. A dot B plus C, B plus C, this is 1. This is somehow coming 1. And this will be again A plus C. A plus C, it is 1. So accordingly, you will be able to prove that this LHS is equal to RHS, and then hence we will prove the statement. So in this way, when you are solving any expression or you are expressing, so what you can do, you will take all the terms and accordingly you will make the truth table and then verify that it is coming up true. Then after doing this part, you will then we are talking about associative law, then absorption law. A plus A dot B equal to A. Similarly, the second will become A dot A plus B equal to A. Then we have the De Morgan's theorem, right? De Morgan's theorem. De Morgan's theorem, what happens? De Morgan's theorem says that it is used basically to find the complement of an expression, right? It is used to find the complement of an expression. What we do that when we are finding the complement, like if I say A plus B bar, right? There are two De Morgan's theorem. A plus B bar is equal to A bar dot B bar. A plus B bar is equal to A bar dot B bar. That's the first statement of the De Morgan's theorem. A plus B bar is equal to A bar dot B bar. Second statement is A dot B bar is equal to A bar plus B bar. That's the second statement. Like sometimes you are asked that what is the De Morgan's theorem, and state them and verify any of them. Now if I say A, B, A plus B, then A plus B bar, then I take A bar, then I take B bar, and then it is A bar dot B bar. Now you see 0, 0, 0, 1, 1, 0, 1, 1. A plus B, 0, 1, 1, 1. A plus B bar, 1, 0, 0, 0. A bar, 1, 1, 0, 0. B bar, 1, 0, 1, 0. A bar dot B bar. A bar dot B bar, 1, 1 is 1. This is 0, this is 0, this is 0. So this one is the LHS, this one was the RHS. Okay, you can say LHS is equal to RHS, hence true. So De Morgan's theorem basically is used to find the complement of a Boolean expression. If you are not asked about stating the De Morgan's theorem, you could also be asked that find the complement of the given Boolean expression, right? Find the complement of the given Boolean expression. Now, if I say, for example, if I have a statement, I just take a Boolean expression. The statement says, find the complement of the given expression, and the expression is given AB plus AC, right? AB plus A bar C, if I say AB plus A bar C, F is equal to AB plus A bar C. I have to find the complement. So F bar becomes equal to AB plus A bar C bar. Okay, it is AB bar plus A bar C bar. Now what it becomes? A bar dot B bar plus, sorry, this becomes dot. AB, break the bar, change the sign. This is AB bar dot A bar C bar. Now this is A bar, again I am applying here the A bar plus B bar, again dot A double bar. So it becomes what? A plus C. See here, F equal to AB plus A bar C. AB plus A bar C. I have to find the complement. F bar is equal to AB plus A bar C, its complement. What it becomes? AB bar, this plus changes to dot. Dot, break the bar, change the sign. This plus becomes dot. A bar C, its bar. Now this was again here AB bar. Again break the bar, change the sign. So it is A bar, dot becomes plus, plus B bar. Dot A bar bar. A bar bar is A plus the C. It will become C bar. Okay? One second. A bar plus C. Yeah. Okay. So this is the finding the complement of the Boolean expression. Then we have a duality theorem. What does the duality theorem do? The duality theorem is used to find a dual. It says that starting from one Boolean expression, we can find another Boolean expression. Starting from one Boolean expression, we can find another Boolean expression by changing each and to or to and, 0 to 1 and 1 to 0. Like again, if I have F is equal to AC plus B dot 1. Right, AC plus B dot 1. Now, when we are finding the dual of this expression, it becomes a dual. So, AC, it will become A and to or to and, 0 to 1, 1 to 0. A plus C dot B. Dot becomes plus 0. So from one Boolean expression, you can find another Boolean expression by changing the and to or to and, 1 to 0, 0 to 1. Right? So this is the duality theorem, that starting from one Boolean expression, you can obtain another Boolean expression by changing the and to or to and, 1 to 0, and then 0 to 1. Okay. Then we have this sum of product and product of sum. To find the sum of the product expression, right? To find the sum of the product expression, what you can do, that you need to get the truth table, all those values where you are getting the output as 1, right? All those values where you are getting the output as 1, for them you need to find the min terms. For min terms, what we do? Min term, 0 is taken as complement and 1 is taken as non-complement. 0 is taken as complement and 1 is taken as non-complement. And in case of POS, what we do? 1 is taken as complement and 0 is taken as non-complement. So it forms the min term as well as the max term, right? Min term and max term. Min term is used in SOP, sum of product, and the max term is used in POS, that is product of sum, right? Students, if you have any doubts, any topics in the Boolean, logic circuits, Boolean algebra, you can put it in the chat, so that while I am closing the session, I will be able to discuss that. Okay, so when we talk about this part, So when we talk about this part again, when we talk about a SOP and a POS, now there are two types of. One is canonical form and the other is the cardinal form of writing the expression. For example, now if I say, I take a truth table. I'm taking a truth table here. A, B, C. And this is F. That's the result. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. The output is like this, random output I'm taking. So it is 0, 1, 1, 0, 0, 1, 0, 1. Okay. So now if I have to find the min term, right? Min term as I told, min term we find of those values where the output is 1. And then we have the max term. Max term we obtain for the outputs which are taking 0, that we use. So if I talk about the min term, where we take the output is 1. Now this 0, 0, 1, A bar, B bar, C. This one, A bar, B, C bar. This one, A, B bar, C. This one, A, B, C. If I have to find the max term here, output is 0. It will be 0 is taken as I told, complement, non-complement. A plus B plus C. This one, A plus B bar plus C bar. Here, A bar plus B plus C. This one, A bar plus B bar plus. I hope this is clear. That for min term, we will use 0 as complement and 1 as non-complement. In case of max term, we use 0 as non-complement and 1 as complement. That is for the max term. Now if I say for this truth table, I have to find the SOP. Now as I told, canonical form and cardinal form. Now canonical, what I'll say? Canonical form I'll say canonical. Canonical I can say F is equal to A bar B bar C plus A bar B C bar plus A B bar C plus A B C. But if I have to go for the cardinal form, I'll say F A B C is equal to, I'll use sigma. Sigma, see how I need to write 0, 1, 2, 3, 4, 5, 6, 7, right? So sigma, where it is coming 1? 1, 2, 5, and 7. So I can say sigma 1, 2, 5, 7, right? This is the cardinal form of writing it. Now again, if I talk about the POS, if I say, what I say? Canonical F is equal to A plus B plus C dot A plus B bar plus C bar dot A bar plus B plus C dot A bar plus B bar plus C. This is the cardinal form. Sorry, canonical form. And if I have to write as a cardinal form, I'll say F A B C is equal to pi, right? Pi. What are the values? 0, 3, 4, 6. 0, 3, 4, 6. Okay. So this is the way of writing the Boolean expression in SOP and POS, right? SOP and POS, canonical and the cardinal form, right? Canonical form and the cardinal form. Whichever you have, you will be asked, you can write in that way. Right, so I hope this is clear, the canonical form and the cardinal form of writing the Boolean expressions. Then again, one thing, solving K-map, right? Then once I complete with the K-map, then I'll come to logic circuits. Any doubts in this? You may type. Okay, so the K-map is basically used to reduce a Boolean expression, right? K-map is used to reduce a Boolean expression, and by the help of the K-map, we can reduce any Boolean expression, we can get the reduced expression. So if I say I have been given a K-map, I'll just directly be solving two questions, so that will make it more clear. Like if I say, for example, I have a question. The question says, F A B C D F A B C D equal to sigma 0 1 2 3 0 1 2 3 5 7 13 15 13 15 8 9 10 11. Okay. Now I make a K-map. Follow the system. A bar, B bar. K-map is important, as I always tell. K-map will give you around 15 plus marks. So A bar B, AB, and AB bar. C bar D bar, C bar D, CD, and CD bar. Numbering 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 0, wherever the values are here, 1, 2, 3, 5, 7, 13, 15, 8, 9, 10, 11. Okay. Simple one, this one becomes, isn't it? We will have a quad, right? This becomes a quad. Okay. So I can say a quad between 1, 3, 5, 7, 9, 11, 13, 15. This is equal to, here you see, D bar, C bar cancel each other, D is left, here A and B, so this is D. Okay. Now a quad between a rolling quad again. Next it will be a rolling quad. This will be like this. Okay. Rolling quad between 0, 1, 2, 3, 8, 9, 10, 11. So this is, here you see from this side B bar are cancelling each other. A bar is cancelling this one. A and A bar. So B bar is here, and this side again all cancel each other. So it is P bar. So F is equal to D plus P bar. See, when we have to reduce it, we look for first for octet, then we look for quads, then we look for pairs, right? Octets, quads, and pairs. If there is such a group where all the members are also members of another group, in that case, that is referred to as a redundant group, and that we do not show. So this part is again K-map here. I'll use one more K-map question so that we can understand it much better again. This one I hope it is clear. I am taking another question. F A B C D F A B C D equal to pi 1, 2, 3, 11, 12, 14, 15. Right? 1, 2, 3, 11, 12, 14, 15. Yeah. Now you see ABCD again here. I'm taking it like this. This one is POS. 1, 2, 3. Here it is A plus B. A plus B bar. You need to remember this part. A bar plus B bar. A bar plus B. This is C plus D. C plus D bar. C bar plus D bar. C bar plus D. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right. Now 1, it will be placed as 0. 2, 3, 11, 12, 14, 15. Okay, now you see here 1, 2, 3, 11, 12, 14, 15. We have this as a pair. We have this as a pair. We can have this as a pair, and we can have this as a pair. We can say pair 1 between 1 and 3. So this is A plus B, A plus B plus D bar. Pair 2 between 2 and 3. 2 and 3. C bar is common here, D plus D bar. Right, so D plus D bar is here, and again A plus B. So we can say A plus B plus C bar. If I have a pair again, a pair 3 between 11 and 15. 11 and 15 you see here, A bar is common, and this side again C bar. So this is A bar plus C bar plus D bar. Again we can have a rolling pair here. A rolling pair between 12 and 14. Rolling pair, so A bar plus B bar, and here you see C and C bar cancel each other, so it is A bar plus B bar plus. Okay, so now what we will say, F is equal to A plus B plus D bar dot A plus B plus C bar dot A bar plus C bar plus D bar dot A bar plus B bar plus D. Okay, and then you will draw the logic circuit. Anyone has some doubt in this schema? You can tell me. If anything to be explained again, I will do so. So the K-map question is very important, and here the grouping is the most important thing, because if you are not able to make the proper group, then depending upon that, your other parts are also dependent on that, so they will also be wrong. So that is. Okay. Next, let us talk about the other part, that is the logic gates. Logic gates, as I have told, logic gates, they are the building block of the digital circuit. We have 3 logic gates and basic gates, exclusive gates, universal gates. Basic gates are the gates which are the building blocks, as I have always told, the basic building blocks of the gates, they are the and, or, and not. The AND gate results a true value when all the inputs are true, right? The AND gate returns a true value when all the inputs are true. OR gate returns true if either of the input is true, right? OR gate returns true if either of the input is true. And NOT gate returns the complement, right? NOT gate returns the complement. The symbols, if I say, and this is the AND gate, or this is noted by A dot B, or this is A plus B, not A bar, right? OR gate returns true if either of the inputs is true. NOT gate returns the complement, A bar. Now, universal gates, NAND and NOR. Why they are called universal? Because using these gates, we can obtain the output of any other gate. NAND, this is AND plus NOT. The output of AND gate is connected to the NOT gate. Like this is this one. Okay. Then NOR gate. Output of OR gate is connected to the output of OR gate is connected to the NOT gate, that is NOR. So NAND and NOR. NAND gate is the complement of the AND gate, and NOR gate is the complement of the OR gate. Why they are called so? As I told, NAND and NOR, using this NAND and NOR gate, we can obtain the output of any gate, right? We can obtain the output of any other gate. Like NAND as AND, right? We have NAND gate and we want to obtain. So NAND, we divide the output into two parts and connect to other NAND gate. This is NAND as AND, right? NAND as AND. Then NAND as OR. Take one input, divide into two parts. Take another input, divide into two parts. Pass it to a third one. This is the output of OR gate. So this is NAND as OR. Then NAND as NOT. You take this, divide into two parts. This output will be NAND as NOT. So NAND as AND, NAND as OR, NAND as NOT. These are the three. Similarly, NOR as OR, NOR as AND, NOR as NOT. I hope you will be able to understand. I'll just draw it for you. NOR as OR. See here, NOR as OR. This is the NOR gate. We divide into two parts. Again connected to a NOR gate. This is NOR as OR. This one now, NOR these two passing. NOR as AND. And then NOR as NOT. NOR as NOT. Okay? NOR as OR, NOR as AND, NOR as NOT.
Okay, so these universal gates are clear. Next, we have the exclusive gates, XOR and XNOR. XOR, I say A bar B plus AB bar. This is the XOR gate. Internally, it is A bar B plus AB bar. XNOR, if I say AB plus A bar B bar. This is the XNOR. Now, based upon these logic gates, we can define the circuits, whichever is there, that we can define. Is it fine, students? Logic gates. Then comes application of logic gates. Here we have encoder, decoder, and multiplexer. That is a part of our syllabus. Encoder, decoder, and multiplexer when we say. And before that, we will talk about half adder and full adder. Half adder circuit is used to find the sum of 2 bits, right? Half adder circuit is used to find the sum of 2 bits. And a full adder is used to find the sum of 3 bits. In half adder, what happens? We find the sum by the XOR gate and the carry by the AND gate. In a half adder, we use the XOR gate to find the sum of the 2 bits, and the carry we obtain by a AND gate. But in a full adder, what happens? In a full adder circuit, if we talk about when we are finding the sum, it is the XOR gate, and for the carry again A bar B plus AB plus BC plus AC, that we get. So when we talk about carry is, as I told, AB plus BC plus AC, and for the sum we have the A XOR B XOR C, that is the full adder. So half adder, full adder, that is the important thing. Again we talk about encoder. Encoder circuit, what happens? Encoder is used to convert any bit, right? Any value, any number system to binary. Like if I say 8 octal to binary, if I have to draw. Just I'll draw for the encoder like this. 0, 1, 2, 3, 4, 5, 6, 7. I have 3 gates here. Now, 0, 0, 0, nothing is connected. This is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. 0, nothing is connected. 0, 0, 1. 0, 1, 0. 1, 0. 3, 1, 1. So this is 1 and this is 1. 4, 1, 0, 0. 5, 1, 0, 1. 6, 1, 1, 0. 7, 1, 1, 1. Okay. So if I select 3, now this and this OR gate gives a high value. So output is coming 0, 1, 1. Okay. So this encoder circuit is used basically to convert any number system to binary. So that is the purpose of the encoder, to convert any number system to binary. That is the purpose of the encoder circuit, right? Similarly, decoder, what it does, decoder is used to convert binary to any value, right? Decoder is used to convert binary to any value. So in that, what we will do, again the same circuit will be there, and accordingly we will be able to solve it. I'll be sharing it. Multiplexer is again like decoder, but in multiplexer what happens? Multiplexer, one logic circuit is there, and again the data signal or the carrier is there, which is used to do it. So when we talk about part 2, section A, as I say, section A, you will be getting 3 questions. The first one will be 1 SOP and 1 POS. 1 SOP and 1 POS, 5 marks each. So there you have to solve or reduce it, and then you will have to draw the logic circuit. Question number 2, it can be either a scenario based question or a story type question, and again you have to make the truth table, then using K-map you have to reduce the circuit, and then you have to draw the logic circuit. Third one, it can be a combination where you can be given 2-3 definitions questions or reducing a question, or you could be given to find the logics or explain any of the encoder, decoder, multiplexer that could be there. So depending upon that, so it is a wise decision to first attempt the K-map, both the K-map. Whenever, as I told again, whenever you are solving the K-map question, you must ensure that you have put the correct values and then you are reducing it properly, because if you are not reducing it properly, whatever you are going to do, that will not yield the, even the logic circuit and all other things, they will be a waste. So that you need to take care. Secondly, whenever we are making the logic circuit, when you are drawing the logic circuit, it has to be neat and clean. The lines have to be straight, right? The lines have to be straight. You draw it using pencil or pen, that does not harm. But if you are drawing it by pen, you must use a black pen, you can use, but there are no overwriting, no scribbling. It has to be proper, it has to be written very well, then only you will be able to take it, okay? Then only you will be able to understand it properly, okay? So that part we need to take care. Again, when you are taking this values for implementation, right? When you are taking these values for implementation, the truth table when you are making, when the story type questions, when I say when you are making the truth table, so that also has to be done very well so that you are able to understand it properly, right? Any queries? Even if you are watching it later on and you find any queries, if you feel like you could send me, you could let me know, so accordingly I'll be able to guide you. Okay. So I hope this much is in Boolean. I'll end the class now. Okay. Any doubts, let me know. Okay, thank you. Bye bye.